Hello, today we are going to talk about how to decompile .NET Framework DLLs and exe files. So these are called assemblies and are the result of compiling, for instance, C# source code. So the decompiler takes a DLL and converts it back to C# source code. Okay, so this is Windows 11 virtual machine. .NET Framework is a technology from Microsoft, is similar to Java. Java has bytecode, the intermediate representation. The .NET Framework has CIL, which is common interface, common intermediate language. Has a .NET Framework runtime, which is similar to the Java VM, and the dominant programming language that is used in order to compile .NET Framework binaries is C#. Okay, so it's Microsoft's response to Sun's Java. Okay, first of all, let's look at the tool. It's called ILSpy. So it has a GitHub repository, which is under github.com/ic#code/ILSpy, a .NET decompiler. We go to releases. There's ILSpy 7.2.1 from this year, April. We have the zip binaries. Let's put them in ctemp bin. Okay, it's a zip file. Let's extract it. Okay, and the executable is this one, ILSpy. This is the decompiler. Okay. So it has already opened some DLLs, mscorelib, .dll, system .dll, system core. So .NET Framework DLLs for .NET Framework 4 reside in C Windows, c:\windows\microsoft.net/framework 64/v4.0. And there's some which reside in the GAC, which is the, let's see what it is. .NET Framework GAC. Global Assembly Cache. It's a directory where both the system and end users can install their managed DLLs. Okay, there's a tool which is called gakutil, which allows you to put files in there. It's kind of similar to c:\windows\system32. That's for Win32 API DLLs, and the GAC is for .NET DLLs, .NET Framework. So there's a difference between .NET and .NET Framework. So .NET Framework has the latest version 4.8, and .NET without a framework at the end is at version, where are you? is at version 6.0.7. .NET was previously called .NET Core. So .NET Framework and .NET are different. We're using .NET Framework. Okay. Let's look at the DLLs that are available in here. So there's a system.memory. These are DLLs from Microsoft, first party system.something. Okay. MonoCecil, that's the DLL originally from the Mono project, which allows you to edit, so to write DLL files, PDB files, MDB files, or binary files, to visualize what's inside of a binary file and to modify it. Okay, Microsoft.something are .NET Framework first party DLLs. Okay, let's look at ILSpy.exe and see if it's a .NET Framework executable. So we drag and drop ILSpy.exe to the assembly's left-hand side tree view in ILSpy, and it says ILSpy version, culture neutral public key, and it seems to be a C# DLL. If it's not managed, ILSpy tells you so. So let's open a Win32 non-managed DLL and see what it says. System32 shell 32 DLL. So this is a Windows Win32 API DLL, which provides functionality around Windows Explorer and the Windows shell. So it says PE file, DLLs and executables in Windows are PE format, which is a file type which starts with MZ, portable executable format. Is a file format for executables, DLLs, object code using 32-bit and 64-bit versions of the Windows operating system. It's a evolution of COFF from DOS executable programs. And then there's a .NET extensions to the PE format, and then there's PE32. Okay, so the executable, if you open the first bytes of it, the binary file, the first bytes are M and Z. Okay, so we've opened a .NET Framework DLLs and exe are called managed files, and this is a non-managed file, shell 32 DLL from C:\Windows\Systems32. It says the PE file, so the DLL, does not contain any managed metadata. So managed files contain metadata about what classes are exported from this DLL, what's their signature, what are all of the types exported from the DLL. So that's metadata. Okay, so let's look at ILSpy. It says it doesn't say that it doesn't contain any managed data, so it's a managed DLL. ILSpy. Manage executable even. Okay, it says where's the path of the executable, ILSpy.exe, and it says that compiled any CPU 64-bit preferred, which means that this executable will run as a 32-bit process on Windows 32-bit. It will run as 64-bit process on Windows 64-bit. Okay. This is the version info block, so it's version 7.2.1. It says it was compiled with .NET Framework 4.7.2. It uses the .NET Runtime 4.0, so even .NET Framework 4.8, which is the latest version, uses the Runtime 4.0, which was used even by .NET Framework 4.0. Okay, it's a .NET Assembly Inspector and Decompiler. Sharp Develop team. Sharp Develop was an IDE, an open source IDE for .NET Framework, Windows only. Okay, if we expand the assembly, we can do the following things. So we can look straight at source code, the source code of a method, for instance. Let's go with ILSpy. This is a namespace, icsharpcode.ilspy. Let's go with about page. So about page is a class, internal sealed class about page, which derives from simple command. So we can look at the source code, and we can select what programming language do we want the display source code to be in. So the most basic of them is IL, which is intermediate language, common intermediate language CIL. This is what's actually inside of the DLL, so this thing converted to binary. That's what's in fact inside of the ILSpy.exe file. Metadata and code compile to IL. Okay, all of the public classes, types, methods, etc. need to be accessible from outside of the managed DLL, so the names of those methods and public classes and public methods needs to be exported by the .NET binary, by the .NET assembly, by the managed DLL, in order to be used from another DLL. There's a possibility of obfuscating code such that it doesn't look this good when decompiled to C#. Let's select Visual Studio 2019 C#8. So the source code looks really readable, human readable. And if we look at local variables, even the local variables that are defined inside of a C# method, so C# methods are C# functions which are member of a class, even static methods, which are so static methods are part of a class, and non-static methods are part of a object, which is a instance of a class. Okay, so in this case, update settings is a method on the objects of the class update settings. It has as parameters always the hidden parameter this of the same type as the class. In this case, it's the class update setting. So in here there's a hidden parameter called this. Where are you? And there's the second parameter, which is the visible one, which is xElement section. We can navigate all identifiers. So xElement is an identifier, is the name of a class. We can navigate to it by clicking on it. It navigated to system.xml.linQ.xElement, which is the full name of the class, which is from the DLL system.xml.linQ.dll, which comes from the GAC. We can go back to our method, which was called where are you? About page. Where is it? About page.cs, which is the file. About page class, and inside the class there's another class which is called update settings. So the full name of the path is ILSpy, which is the name of the DLL, and then about page, which is the name of the first class, and then .update settings, which is the name of the second class. So the class update settings is embedded inside of the class about page. Okay, and the method update settings of the class update settings has a second parameter of type ILSpy settings named settings, and there's a local variable named xElement of type xElement, and this is a method variable of this class. So the class is named update settings. The member is named update settings.automatic update check enabled. Okay. So this is a cast to a nullable bool. This is the question mark operator. If this entire thing is null, then it makes no sense to convert it to bool, or they don't want to do that. So it will, so this is not null. This XML element will be converted to bool. If it's null, then the member variable automatic update check enabled will have the value true. So the source code of methods is extremely readable. We can see what exceptions are caught in catches. We can see a really clean and human readable source code, indentation, named of internal of local variables. And for private methods that maybe don't have their signature exposed via C# metadata, or can have their names changed in C# metadata by a C# mangler obfuscator. So nobody obfuscated the source code, the original C# source code, so the private identifiers have the same name as in the C# source code. So there's a .NET obfuscator step. So .NET obfuscator takes the C# source code, it converts it in a way that the if compiled, the generated managed assembly is equivalent to a managed assembly that was compiled straight from the source code, is an intermediate step between source code and the compiler. So the obfuscator takes the original C# source code, converts it to equivalent but really hard to read by humans C# source code, and then that thing gets compiled by the C# compiler. And then when you decompile that managed assembly, that DLL, the source code will be really hard to read by humans. That's the entire goal of obfuscators, to make the decompiled managed assemblies C# source code look really awful for humans. So they do that. Okay, so they do that by, for instance, changing the names of all local variables, of all of the private identifiers to A, if possible, to the letter A. If not possible, then to the letter B. If not possible, to the letter AA. And by doing some source code transformations such that a while becomes a for or stuff like that. Go-tos everywhere to make the C# source code that's decompiled as hard to read as possible. Okay. So navigating the code in the assemblies tree view and then decompiling that thing is interesting. For instance, you can decompile just a single enum, but even the most powerful feature of ILSpy, you can select many assemblies in the assemblies tree and go delete. They will be removed from the assemblies tree view. So the most powerful feature from ILSpy is to right click on an assembly and say save code. Let's pick a place. So let's name the directory decompiled. That. We keep the default file name and it saves it as a C# project. Save. So we've selected Visual Studio 2019 and the first version of Visual Studio 2019 and its associated C# version, which is 8.0. As a language to decompile to, we have selected C#. In previous versions of ILSpy, it can also decompile to visualbasic.net. Right now, the current versions of ILSpy can decompile to any version of C#. So there's C#1 to the latest C#10. IL with C# comments. I don't know what's the difference between IL and L with C#. Ready to run, I don't know what this thing is. I usually use, so 99% of the time I use C# and 1% of the time I use IL to look at the actual source code that's in there. And when decompiling to a newer version of C#, newer versions of C# have sugar syntactics, such as the, things that did not exist in previous versions of C#, such as async, linq, etc., which don't convert to IL, but instead they generate intermediate code, and that's then compiled to IL in order to run on the .NET Framework runtime version 4. I will show you this if possible. Okay, so it's important the version of C# language that you use. If you want to see what's behind all of the sugar syntactics, you go with the old version of C#, such as, I don't know, C#4. Yes, 4. Okay, so 4 has support for .NET Framework 4, runtime 4.0, and even the latest C# version compiles down to the .NET Framework runtime 4.0. But the syntax of C#10 is different from the syntax of C#4. So what it does, it converts C#10 syntax to C#4 syntax in order to be able to compile for the .NET 4.0 runtime. Okay, really useful to see what's behind C# async and other features which are sugar syntactics. The question mark operator, for instance. Let's look at that. So about page, this thing, and then there's the sealed class update settings, and then in the method update settings there's question mark. So let's convert that to C#4. About page, sealed class update settings. So it seems that question mark existed in C#4. But it did not exist in C#1. So it's decompiled to, so let's put them side by side. The update settings methods. Copy, where's WinMerge, new. So on the left side we'll have the older, which is C# version 1, and C# version 8 in the right hand side. The class is called update settings. The method is called update settings. Control C, Control V, and then refresh. And we need to configure it to wrap lines. Editor. How do we tell it to wrap lines? View. Wrap lines. This guy. Okay. So let's put a comment in here. // So on the left hand side we have the older C# syntax, which is C# 1.0. And on the right hand side we have the newer syntax, which is C# 8.0. So again, C# 8.0 has the question mark binary operator. That does not exist in C#1, so when decompiling to older versions of C# that don't have question mark operator, ILSpy converts it to so this thing until here. is X element automatic update check enabled. This returns an X element. That's then converted to bool question mark. So bool question mark does not exist in C#1. The CLR type behind this thing, so question mark is sugar syntactics around nullable, less than, and then greater than. So this thing is C# sugar syntactics over nullable, less than, bool, greater than. Then there's this pair of parentheses. So these two are equivalent. And this is captured in a local variable named flag, which is of type nullable bool. And then we go question mark, question mark. So this is a nullable bool, so it has three values: null, true, and false. You see if flag is null by looking at the member has value. So if it does not have value, then flag is null. Then so if it's not null, then it will put a value true in the automatic update check enabled member variable. If it does not have a value, if it's null, then it puts in the member variable the value of flag.get value or default, which is, it has a value because we know it has a value, so it will be just true or false, whatever is stored inside of this thing. Okay. Then again, datetime question mark is sugar syntactics for nullable datetime. Okay. Let's look if this thing has a sync. Sync. About page. Yes, about page has async in the method in add update check button. Let's go there. Control F, Control V. Next. So this is C# version 8 of the method add update check button, and has an async in here. So let's copy the method, put it in WinMerge, a new page. So new C# 8, Control V, and let's look at the version of this method, Control A, Control C, in C#1, Control F, Control V, file next. Okay, so here comes the generated source code. Control C, Control V. Okay, next. Oh, so it was more than that. Okay, Control C, Control A, Control V. Okay, next. define next the method. Control C. What else? So that's it. It has a class and a method. Okay. So this 10 lines of C# version 8 code, before being compiled to IL, is actually desugarized and converted to this C# source code that you see in the left side of WinMerge. So there's a compiler generated private sealed class with a named less than, greater than C __ display class C _0. So a name which is should not conflict with the source code written by hand by the developer. Okay. And then the actual method has the same signature, so private static void add update check button stack panel decompiler text view, the same signature. But the body of the method is totally different, so it says new of the intermediate class. The new object has a stack panel, which is this guy. It has a text view, which is this guy. And where's the text view? This guy. So this is a captured variable captured by this anonymous function. So captured variables live outside of the scope of this anonymous function. And in order to be converted to .NET runtime 4.0, these captured things need to be member variables. So text view is this member variable, button is this member variable, in order to be accessible from this body of the anonymous function. So the body of the anonymous function becomes a simple method, and the captured identifiers become simple members of the class of that method. Okay. So we have stack panel children clear, which is where show available version. There's no such thing. Okay, so the anonymous function is in fact what? Async state machine. There's an attribute that I did not know existed. Let's see where show available version has ended up in where. So Control F, Control V, enter. So catch exception X, Avalon text edit output, new Avalon text edit output, text output extensions, write line, this guy, Avalon text edit output, x to string. So this is, I'm going to guess, an extension method. Extension methods did not exist in C# version 1.0. So again, it's syntax. This is syntax, sugar syntax for this thing, for the type of the extension method, the static extension method, the fact that the first parameter is this, and then this is the second parameter. Okay, text view is captured, so you access the member variable of the intermediate of the local class instance. Yes, show text, Avalon text edit output. Okay, show available version. Okay, next, stack panel, children clear. So stack panel is captured, so we use the member variable of the local temporary class instance, then children clear, available version info, available version. So available version is await get latest version async. So there's no await keyword in C# version 1. So we need another class, which is another local instance, class instance, which is called the waiter, which does get latest version async and then await. So await, what does await do? What does it do? I know. Wait. It's equivalent to the getResult method. It blocks until this block finishes. Let's see what getResult, what a waiter is. So a waiter is task awaiter of available version info. There's the default keyword that apparently existed in C# version 1, probably for initializing C# structs. Okay, so for me, ILSpy is really useful. I decompile source DLLs that have, I don't know, for instance, bugs, or I don't know how to use them or what they do. I can see the source code and I know I can determine what the source code really does. Another usage that I have for ILSpy is this one, to desugarize C# syntax. It's really, there's moments when I need to know what await does, what extension method does, what async delegate does. No? Even if the desugarized source code is way longer than the sugarized one, the desugarized one is really easy to follow. It's linear, it's just simple classes, simple structs, simple methods. If I were to run with a debugger inside of the desugarized source code, I know exactly where the debugger will step. So if I put a breakpoint in here, I go F10, step to the next instruction, it will step here. And then F10, it will step here, and then it will step here, and then it will step here. Everything is linear. There's less go-tos and the debugger jumping all over the place, which happens with sugarized async C# source code, or with yielding. When you yield, the debugger will jump outside of your method to the caller until you can yield again and stuff like that. Okay, so desugarized longer, but easier to follow for me, at least. And I don't need to read a ton of Stack Overflow questions in order to understand what really happens behind this piece of code, which sometimes is necessary in order to improve the source code, because almost nobody knows how to program C# async correctly. Okay, and if we have .NET, if we have Visual Studio, we can recompile back the decomiled csproj. So the decompiled source code has a csproj, this thing, ILSpy.csproj, which is a Visual Studio project. So we can install Visual Studio and open ILSpy.csproj in Visual Studio, and then we can go rebuild the solution to build an executable which is called ILSpy.exe, which is a managed assembly, which will work just as good at this ILSpy.exe file that I have downloaded. So let's see how far we can go with this. Control T. We need Visual Studio. Okay, the official page. Let's go with the latest version, which is 2022. Download Visual Studio. Let's look at what's the difference between editions. So there's Community, Professional, and Enterprise. What's the difference between them? Professional is good enough for my uses. Let's compare them. Where are you? Learn more. Editions. Compare Visual Studio editions. So from what I see, Community is kind of identical to Professional. The limitation is non-enterprise organizations. Yes, that's me. Up to 5 users, that's me. And the rest is less code length, which means Git hints shown directly inside of the source code editor. I don't use such a thing. Identical, so this column is Visual Studio Code, the first column, the second column and third column is Visual Studio Professional. So for my use case, they're identical. Okay, identical. And the price is free download. Let's see what that is. So we go with work to delete, save. So it's a online installer, just 1 megabyte. Let's run it. Okay, Visual Studio installer. Before you get started, I know. This is an installer for Visual Studio Installer. This is the online installer of Visual Studio Installer. Okay, so it has pre-selected to install Visual Studio Community 2022. What do I want to install? Not mobile, .NET Desktop, yes. Not Node.js, not Azure, not Python. Web applications, not now. C++, not now. UWP, not now. Mobile, never. Unity, never. Game, never. Data science, data storage, extensions, no. Office, and Linux. Okay, so it says .NET Framework 4.7.2 development tools, correct. .NET Desktop development tools, C# and Visual Basic. Okay, we don't need older .NET frameworks. WCF, no. SQL Express, no. MSX, no. JavaScript, no. Windows App SDK, C# templates. Okay, so looks okay. Core editor. Installs 6 gigabytes. Okay, so it needs to download 2 gigabytes of things, and then installed it will take 6 gigabytes. Okay. So this is the C# project that we're going to open in Visual Studio and then build, and we will get as build artifact ILSpy.exe. So how does a C# project file look like? So it says it will build a binary for .NET Framework 4.7.2. C# language version will be 8.0. It's going to optimize to have C# unsafe. Okay. Uses WPF, which is XAML, which is a .NET Framework has two main frameworks for generating UI. The first is called WinForms. System.windows.forms. It's just wrappers around existing Windows controls, Win32 controls, such as button, so native controls, button, window, etc. And then there's XAML, which is an XML file format, which is used for WPF, Windows presentation form, which in C# is the foundation, the DLL system.windows. So not system.windows.forms, that's WinForms, but system.windows. So in an XML file, you define how the UI will look like, and you can have things like put a button inside of a button inside of a text view and stuff like that. So web style embedding of controls in other controls. So inside of a button, for instance, you can put a web browser. Things that are not so easily possible in system.windows.forms. And Microsoft Silverlight was a web browser plugin which also used XAML. XAML is also used for other things, such as automation in Azure DevOps, which is the CI/CD software from Microsoft, and recently is used in the cross-platform WPF, which is named MAUI. Okay, so it says sign into Visual Studio. Not now, maybe later. Development settings, I'll go with C++. Dark, okay, start. Okay, so this is the application named Visual Studio Installer. In here we can see that we have installed Visual Studio Community 2022. The version is 17.2.6, and we can install other elements of Visual Studio Community 2022 that I didn't install. Okay, and then I can install other versions of Visual Studio and other what's the name? Other editions of Visual Studio Enterprise or other versions of Visual Studio. Okay, so one is enough for me, Visual Studio Community 2022. I can close this application. So now Visual Studio 2022 has started. I can go, I don't know, continue without code. Let's see what this is. I don't need it. Let's work side by side. So left is work and right is doc. So let's drag ILSpy csproj there. Okay, so it has loaded a huge csproj. It has created a solution for us. Let's save the solution, 5, save all. It suggests that the name of the solution is ILSpy, yes. The extension is .sln, save. So it has created this file, ilspy.sln. And now we can go, let's go with release, any CPU and rebuild solution. So it says failed because duplicate embedded resource items. Yeah, sometimes the source code that's decompiled has 2 or 3 bugs that you need to fix. But most of the times you can really recompile that thing. The .NET SDK includes embedded resource items from your project. Or put false where? Okay, let's not try with ILSpy. Let's try with a simpler DLL. File close solution. What is this? Why are you showing me this? Okay, left. ILSpy back. Let's find. Okay, so let's take another DLL. When you open an assembly in ILSpy and you start navigating the source code, it will need to load all of the other DLLs in the assemblies view. So let's take one which seems to be simpler. Which is that one? This guy, for instance. Right click on it, save code. Let's keep creating new directories until we succeed. Save. So decompile to this A directory. Let's open this thing, csproj. Okay, let's recompile it. Whoa, failed. Feature generics is not available in C#1. Okay, why did I decompile to C#1? No idea. So we should select C#8. This is conservative. Okay. Right click, save code. Let's delete everything. Okay, why can't I file close solution? Don't save. Retry. Retry. Delete it all. Yes. Okay. We select A directory, save. Okay. How do I open this with Visual Studio? Double click on it. Visual Studio 2022. Okay. Okay, let's go right click and rebuild. Where's the error? Where are the errors? View. Error list. This thing. We need a version of the language which is 9 or greater. Okay, not good. C# code decompiler version 9. Okay, let's close Visual Studio again. Don't save. Control A, Shift Delete, yes. All. Okay, decompile again. Save code, A, save. Okay, it finished. Double click on the C# file, on the csproj file. Okay, right click, rebuild. Still failed. Causes a cycle of the type forwarder. Forwarded registry, okay. We just can't find a DLL that can be decompiled to csproj and then compiled back again. This LZ4 thing, this is certainly going to work. Okay. So LZ4 is a compression algorithm. I'm going to guess that this DLL is really small. Save code. Let's create a new directory, B. Save B. Double click on the csproj. The reference assemblies for .NET Framework version 4 were not found. Okay, let's see how easy is that is to fix this thing. Not easy. So the solution is here to make it not target .NET Framework 4.6 but 4.7.2 .NET Framework version that we have Visual Studio toolchain for, so we can use that toolchain to compile. That's usually from right click on the project and then properties. but then something wrong has happened. Okay, so this was it. Using ILSpy, you can convert DLLs to C# of various C# versions. You can look at the source code. You can convert the entire DLL to source code by using right-click Save Code. You can compile back the entire DLL or just a method or just a class. You can look at the source code. You can grab the source code. Okay. You can go for a class. Not like this, but like, where are you? Alt 7, Alt T, class, like this. Okay. So you can grep, really important to do that. You can see exactly what the method does, and then you can desugarize source code by decompiling both to a new version of C# and to an old version of C#. So that was it. Thank you.